learn about multiplying binomials. So, yay. So if you have a number that, if you have two numbers that look like this, 2x plus 3 times, for instance, x minus 5, okay? These are called binomials. Remember that? Because there are two terms. There are two terms, and you're going to multiply them together. Okay? So there's a few different ways to do this. Okay? The first way that I'm going to show you how to do this is with something they call an area model. So if you were to take a rectangle, is this a rectangle tool? Is that a rectangle tool? Where's my shape tool? Is that my shape tool? I don't know. This. Okay? So if I were to take a rectangle, just any rectangle, and draw it like this, it doesn't have to be proportional or anything. I can divide that rectangle up, okay, like this and like this. And then along the sides of the rectangle, this is a nice way to do it because it helps you stay organized, stuff like that. You call one side 2x plus 3. And then you come down on the side, and guess what I call this? X minus, I would put the minus 5 right here, okay? And then basically, this is called an area model because you're finding the area of each one of these boxes, okay? How do I find the area of something? Multiply the base times the height, right? So what is 2x times x? 2x squared goes in this box right there. Yes? You follow that? Okay, 2x times x gives you 2x squared. What's 3? So the width of this one is 3, and its height is x. So what's, or length times width is, what's 3 times x? What goes here?
3x.
3 times x. Okay? What goes in this box right here?
Negative 10x.
Negative 10x. Is there any questions, anyone, so far? Are there any questions?
Negative 15.
Okay. Thank you,
Oh, for you,
Maria. And down here goes negative 15. Okay? And that is called the area model. And then what you have to do is you have to combine your like terms. Okay? So this goes by itself. These two are called like terms because they both have x after them. Okay? So I have to combine those two. So altogether, I have 2x squareds. How many x's do I have? What's minus 10 and 3?
Negative 7x.
Negative 7x. Thank you. And then I have, what goes here? What else do I have? Minus 15. Okay? So, whoops, I forgot the one. So if I multiply this together, that's what I get. 2x squared minus 7x minus 15. Okay? I'm going to show you two more methods to do the same thing. Okay? To do exactly the same method. So this is called an area model. Okay? In your book, what they do is they break this into, it gets confusing the way they do it in the book. They put this, make this, they
You
go,
also call it the box model.
they go 3, call it the box model, they go 3 this way, and then they go 5 this way. Okay? Well, I guess it's not that confusing. 1, 2, 3, 4, 5, and then they go straight down like this. So altogether I would have 15 boxes here. I'd have 3 boxes that are worth x each. I would have 10 boxes here that are worth x each. Oh, because they go 5 times 2x squared. So these are x big, I think, and this is x. So this would be 2x squared, where it's 2x. This would be x, and this would be x. But I kind of like, should I show that way too? No.
What's your other 2 ways that you're going to
Well, in the book, they divide this up. They they divide it up even more, okay? They say that this is x, and this is 1, 2, 3. So this is 1, 1, 1. So this represents 2x plus 3. See that?
It's very visual.
And very visual. And then going down this way, they have x, and then they have minus 1, minus 1, minus 1, minus 1, minus 1. So each one of these represents minus 1, minus 1, minus 1, minus 1, minus 1. So then each box has its own value. So here, x times x gives you an x squared. X times x gives you an x squared. 1 times x is x. 1 times x is x. 1 times x is x. And this is negative 1 times x. So that's negative x, negative x, negative x, negative x, negative x, negative x, negative x. You can see why I don't like doing this method because it takes a lot of space. And all of these are 1 times negative 1. So all of these in here are going to be negative 1s, right? Negative 1s. And then so if I add all those up, I get my 2x squareds. I get 3x minus 10x, which makes negative 7x. And then I add up my negative 1s, which makes negative 15. See, that's another way to think about the same thing.
If that's
Okay.
helpful, that's what you do.
If that's helpful, that's what you
That
do.
works for you? I feel like that's
That's
Right.
too much.
Shh. Stop the wrestling over there. All right. So the other method, 2x plus 3 times x minus 5.
Can you show us this method again?
Yeah, I'll give you some more practice, but first I'm going to show you some other ways. Okay?
Hey, you guys make sure you don't are listening to music. There's about 4, maybe 5 of you that are dialing up your iPod.
Yeah, and I don't think I've recorded this on YouTube yet, so I don't think you could hear me speaking. So you shouldn't be listening to the iPods, because correct me if I'm mistaken, but has anyone done this before? No. So I don't know why you would have an iPod. Right? So the other way is called the FOIL method. And this is very
Fun.
fun, which stands for fun or, I don't know. It stands
Interesting learning.
in fun, only interesting learning. No, it stands for first. First, you might want to write this down. First, outer, inner, and last. Okay? That's what FOIL stands for. And so what that means is you're really doing the distributive property, but you're going to multiply the two first terms together. So what's 2x times x? 2x squared. Then you're going to look at the outer terms. Okay? Outer means on the outside. Okay? Someone else. What's 2x times negative 5? Tony.
Yeah.
What's 2x times negative 5?
Isn't it like 10x?
Negative 10x.
Negative.
Okay? Negative 10x. What's 3 times x? 3 times x.
Oh, wow.
3 times x, Matt.
3x.
3x. Okay? What's 3 times negative 5, Grace? Negative 15. Okay? And now I'm going to combine my like terms. So since these are the only like terms, right there, I have 2x squared minus, what's minus 10 and plus 3? Michael, minus 10 and plus 3?
Negative 10 and plus 2?
Yeah. Negative 7x minus 15. So this is the same, oops, I forgot to do last, okay? Those are the two last terms, 3 times negative 5. And it should make kind of a funny looking face, where this are his eyes, this is like his nose, his mouth, and his eyebrows or something like that.
The foil face.
The foil face. So it's first, outer, inner, last, okay? And notice that I got the same result, okay? Okay, one more method that you could use to do exactly the same thing is called the distributive property, okay, which we've done already. So to do that, will this go down? Okay, let's do it using distributive property. Distributive property. And it's just another way to do the same exact thing, okay? What was my original 2x plus 3? 2x plus 3?
Yeah.
Times x minus 5? 2x plus 3 times x minus 5. And so what this means is, when this is equal to 2x times the quantity, which means in parentheses, okay? 2x times x minus 5 plus 3 times x minus 5. So basically what I did is I separated this out into two separate things. 2x times this plus 3 times this. What's 2x times x? 2x squared. What's 2x times negative 5? Minus 10x plus, now I'm going to distribute through here. 3 times x is 3x, and 3 times negative 5 is negative 15. And again, whoops, that should be an x squared.
I was like,
And again, Mr. Muscala,
love it. Love it.
Mr. Muscala,
How did dx?
2x,
2x.
2x squared.
Sorry.
You know what I had for breakfast this morning, Mr. Muscala?
No.
I had 2x and pi. Yes, 2x and pi.
2 eggs and pie.
Wait! Mr. Muscala's getting me all messed up.
Sorry.
Right, wait! This button, the red button would stop. So 2x squared minus 7x minus 15. I get the same result again, okay? So 3 different methods to do the same thing. Each time you'll be asked to do it 3 different ways. You'll be asked to do it. So now we're going to do a you try, okay? Let's try this one. Let's make it easy. You try. You try.
You try.
You try. Okay? Let's try this. Let's do an easy one. X minus, I'm going to call this h instead of times x, no, not h. X minus, I don't want an h.
4.
X minus 4, thank you. Times x plus 2. Let's do an easy one. Ready, start. Who can tell me the answer? Wait, says he got it. Go ahead.
You got mad at me. X squared.
X squared
Negative 4x.
minus 4x negative 8. Is that right? You're missing something. What am I missing?
Is it minus 2x negative?
Plus 2x minus 8.
Plus 2x minus 8. And then I got to combine these two. What's minus 4 and plus 2?
That's minus 2x minus 8.
Minus 2x minus 8. Okay? How many of you got that one?
I love this box method.
Okay.
This box method is awesome.
Okay, try the box method.
You're eating, right?
What's this?
Try the box method for this one. Ready? You try again. Let's try this. 2n minus 7 times n plus 1. Okay? Let's, I want to get rid of that ugly thing I just did. N plus 1. Okay? You try. Who's got the answer? Wait, raise your hand. Maria's got it. 2n squared, what?
Minus 5n.
Minus 5n. Go ahead.
Minus 7.
That's right. Okay. Hey. That's the correct answer. 2n squared minus 5n minus 7.
Yes.
Yes. Okay, I'm going to show you with the rectangle method. Okay. box method, okay?
I like
That's
that
our
box
center.
method.
Turning up, turning it back on. Okay, so the way, did you use the box method,
Yeah.
Maria? So
Best ever.
what she probably did is went 2n here minus 7 over here.
Exactly.
And here, and plus 1 over here. This times this gives you 2n squared, okay? This times this gives you minus 7n. This times this gives you plus 2n. And this times this gives you minus 7. Then she put these two like terms together, and she gets 2n squared minus 5n minus 7. Okay? And that's how you do that. All right. One more thing that you're going to see, okay? They're going to give you a problem that looks kind of like this. They like to do this on the CSAPs. And I like to do that, well, you don't have CSAPs this year, but they like to do this in general. You'll see one like this on your quiz, and you'll see this one like this on your test, and maybe the rest of your life. So, maybe not the rest of your life, unless you're a math teacher. Okay? Rest of your academic career. So, what they like to do is have something, a rectangle inside a rectangle, like that, okay? And they'll say, Farmer John is making a garden, okay? And they'll say, that's not his garden. Here's his garden out here, okay? Or he's planting a concrete walkway or something like that.
No,
okay?
he's making a garden with a nursery.
A garden, okay? And he says, they want to know the area of this part, okay? And they'll say, where are you going? And they'll say this part is like 2x plus 3. And they'll say this part is x plus 1 or plus 5 or something. And then they'll say this is x over here, and this is 2x minus 1. And they'll say find the area of the shaded region. Find the area of the shaded part. So, how would I do that just theoretically, like the big picture? What would I have to do to find the area of this shaded part?
Well, naturally, you have to solve the inside and solve the outside and subtract.
Very good. So what Freddie just said is exactly right. What you want to do in this type of problem is find the area of the big rectangle, and then take the area of the little rectangle, and if I subtract the big rectangle minus the little rectangle, I will find the area of this shaded part. Do you understand that? Okay, so basically you have to do the FOIL or box method twice, and then you have to subtract what you get. So I'm going to do the FOIL method, 2x plus 3 times x plus 5. And I'm going to subtract 2x minus 1 times x. Okay? So here I'm going to FOIL. I'm going to get 2x squared plus 3x. 2x squared is the first outer, whoops, I didn't do outer first. I should have done that first. Plus 10x. Why did I write 50? I don't know. Plus 3x plus 10x plus 15. Okay? And then from that, I'm going to subtract this times this. What's this times this? 2x times x. 2x squared. And what's minus 1 times x? Minus 1 times x. Minus 1 times x. Negative x. Thank you. Who said that? Mary. Very nice. Okay? So now I have to subtract this from this. Whoops, that should be a 2x squared, right? So what's 2x squared minus 2x squared? How many x squareds do I have left?
0.
0x squared. 3x and 10x makes 13x. What's 13x minus negative x? So what's, how many?
12x.
No, it's minus minus.
Oh, positive.
Positive 14x. And then I have 15 minus nothing, so I have plus 15. Okay, so that's kind of a tricky problem that you're going to see on your own. I think you are done listening to me, aren't you? That's okay.